Welcome to the second video about discriminants. In this one, we're going to actually walk through example 1 really carefully and make sure that it makes a lot of sense to you. And then I'm going to encourage you to try number 2 on your own. So this is really for slides 8 and 9. How many real roots does the quadratic y equals 3x squared minus 5x minus 2 have? First step, we need to identify A, B, and C. Those are the letters that are used in the discriminant formula. And if we know what they are, we'll be able to do the whole problem. The coefficients in the equation are A, B, and C, and they're in order in the equation. So, just the numbers, not the x parts. So A is 3. B is -5. C is -2. I'm literally taking those numbers from the equation and just identifying them with letters. Next, we need to actually find the discriminant. So we have a formula for that. The discriminant is always b squared minus 4ac. I set up for you some spots for you to actually put the numbers in. So we're going to have to put b in that first spot where it has a blank space for b. So -5 in the first spot, 3 where it is a, and -2 where it says c. So those numbers go in this order. Watch out. Notice how the arrows cross each other. It's not directly in the same order. And then it gets kind of interesting. Those parentheses that I put are not a joke. That -5 is inside the parentheses, which means you're going to get a positive 25 back. Because if you do -5 times -5, you will get a positive 25. In the other part, if you do -4 and times, or if you do -4 times 3 times -2, you're going to end up with a plus 24. So either that's because you actually do it as plus the -4 and you multiply -4 times 3 times -2. That gives you positive 24. And that's my recommendation. Just do it as plus a negative, -4 times 3 times -2. But if that feels weird, if you're like, is it a minus, is it a negative? If it's a minus and you don't use it as a negative, you're still going to end up with minus a -24, which is still a positive 24. So if that was confusing, replay that. Or you could type it straight, the whole thing in the calculator. Parentheses -5, parentheses squared, -4 times 3 times -2, and then you're done. But I just wanted to clarify that how I did it. I got 25 plus 24. My answer is 49. Right now, I'm less concerned about the actual number for this problem because it's just asking how many real roots. It's not because it's 49, it's because it's positive that I'll be able to answer the question. So a positive discriminant, the positive discriminant, because the discriminant is positive, there are 2 real roots. Look back at the earlier notes for reference of that situation. All right, your next things that you need to do are independent. So first, write down at least 3 things that you notice about example 1. And then once you've noticed those 3 things and wrote them down, then you're going to actually try example 2 yourself. So you're going to look over example 1, watch this video as much as you need so that you can actually succeed at doing number 2 without me. And you can certainly check your work in the rest of the slides. So please, please, please pause this video now. Pause it. No, like pause the video. Pause the video because next I'm going to show the example 2 briefly and I don't want you to see it before you're done. Example 2 coming up in 3, 2, 1. That's example 2. Look at this only if you've done the problem to see if you did it right. And check your answer, not just that you got the negative 79, but also that you therefore said that the discriminant was negative and there are 2 imaginary roots. So I'm going to say that's the answer to check your work. I'm going to go back and I'm going to say continue to try this problem. All right, good luck.